What's up guys, and in today's video we're going to be looking at how we can differentiate different functions that are a product of two different functions. That is f of x equals g of x times another function u of x. Now to differentiate this, we're going to be using the product rule, which is simply summarized by this equation here. f dash x equals the derivative of the first function times the other function times the first function times derivative plus the first function times the derivative of the second function. So we're going to look at how we can use this with some practice examples. So in the first one, we're asked to find dy dx when y equals root x times 2x plus 1 cubed. So the first thing I'm going to do is label my functions, the different functions I have here. So g of x, one of my functions, is root of x, that one right there. And then the second function we have here equals 2x plus 1 cubed. As you can see, they're times by each other. And that's a dead giveaway that we need to use the product rule. So now, applying this formula, we've got f dash x will equal the derivative of root x, which is x to the minus a half, times u of x, which is 2x plus 1 cubed, plus root of x times this function, the derivative of this function, which is a little different because we need to use the chain rule here. So differentiating the outside bit, we get 3 2x plus 1 squared, and now we need to differentiate the inside part, which is just going to be times 2. So if we simplify this, make it a little bit nicer, we get f dash x will equal 2x plus 1 cubed on square root of x plus square root of x times 6 2x plus 1 squared. You could simplify it further, but there's really no need, and that would give you your answer of dy dx. Now the second function we have second question we have is very similar, and we're asked to find dy dx if y equals x to the 4 times 1 minus 2x squared. So simply I'm going to label the functions again as gx and ux. So gx is this one here, x to the 4, and ux is just going to be the other function, or the other part that's multiplied by x to the 4, which is 1 minus 2x squared. So again, just applying the formula, f dash x, or in other words dy dx, will equal the derivative of gx, which is 4x cubed, times ux, which is 1 minus 2x squared, plus gx, which is x to the 4, times the derivative of ux, which in this case we're going to have to use the chain rule again, which is simply going to leave us with 2 times 1 minus 2x times minus 2. So simplifying, we get 4x cubed, 1 minus 2x squared, minus 4x to the power of 4 times 1 minus 2x. Again, you can simplify it further if you want, but there's really no need, because extensions of this question would be to find the gradient at any point on this graph, and you can simply sub in that value of x into that equation, or that derivative function. Now, the final question we're going to be looking at is very similar again, where we're going to find dy dx of this function here, and again we're going to be using product rule. So I'm going to label the functions again, gx and ux. So you can see the two functions that are multiplied together to give you y. So that's going to be x squared and x squared minus 2x to the power of 4. So again, just utilizing the formula that we have, dy dx is just simply going to equal gx, or the derivative of gx, which is 2x, times ux, and then plus derivative of ux, which again is a little complicated because we have to use the chain rule here. 4x minus 2x times by the derivative of the inside part, which is going to be 2x minus 2. And now we need to times all that by gx, which is x squared. Now if you simplify that, make it a little bit nicer, we get dy dx equals this, about 4. Oh, sorry, that should be the power of 3, plus 4x squared, x squared minus 2x cubed times 2x minus 2. So that's the gradient function for that particular graph, and that would tell you the gradient at any point on this graph here. So yeah, you could simplify it further, but there's really no need. And yeah, hope it helps.